Today, what we are going to do is we are going to look at a package called Astrowrap that we have been writing for astronomers specifically. It takes many interesting programs, methods that are available in R that astronomers should perhaps been using but have not been using. And we started looking at this mainly from the KDD guide, the data mining guide with the International Virtual Observatory community. So a long document has been put together there by a few astronomers, and section 7 of it in particular talks about methods that astronomers should really be using. And for many such methods, there are packages that are already available in R, and with most packages in R, there are some examples available, but many times these examples are from biology or some other science. And then if we want to initiate astronomers into that, that's not a perfect thing to do. And that is why what we have been doing is that put some astronomy data sets together which can be used with that. And Astrowrap essentially takes these and puts them together. And this work is in collaboration with Tejas Kai in Pune. And so the kind of data sets that we have been using here are historical data sets, interesting small data sets, and also some very modern data sets from large sky surveys like the Catalina Real-Time Transient Survey. And with these, we provide some worked out examples so that astronomers can directly jump in, take a look at them. So these will also be available on the sister site for this workshop. So using Astrowrap, like everything else in R, is fairly straightforward. In the console, you would load the library simply by saying library Astrowrap. Here, both the R's are capitalized the way they are for R. And then once you have done that, you can use the standard question mark Astrowrap to figure out which all packages are available within Astrowrap. So there is a list of different statistical tools that are available, and one-line descriptions for each of them is given. Don't try to read what you see on the right, because that's too long a list. And so one of the commands, for instance, one of the tools that you can use is LM, something that we had visited in the very first talk, the linear regression related thing. So for each of them, you can again give greater help by saying something like question mark Astrowrap _ LM, and that will give you more details on that particular method. So the documentation on the test includes the relevant astronomical data set as well as how to use that particular data set. And there will be a few default methods like the plot method that will be available with each of them. And so here are some of the tests that we have covered. There is the regression analysis, simple linear model that I mentioned, and then generalized linear model as well, ANOVA, and within clustering there is hierarchical clustering and K-means clustering. On the right-hand side, the plot that you see is the output of one such K-means clustering. The three different types that you see in that plot are three clusters that were returned by K-means, and we'll see the example in slight more detail in the next couple of slides. Then there are also tasks for dimensionality reduction, principal component analysis, which allows you to take lots of different dimensions in a given data set and see which of them are dependent on others and reduce them to a more usable set. Or linear discriminant analysis that is used a great deal also. So we'll see later on a brief example of that, and other commands like biplot and bootstrap, etc. The data that have been included have CRTS light curves. So these light curves, again, as I mentioned, come from the Catalina Real-Time Transient Survey. There are as many as 500 million light curves, and those data points are over a period of 10 years. And that is a fantastic time series data set and can be used for most of these tools in a fairly straightforward manner. Then there are some older data sets like the Faber-Jackson data set, which provides absolute magnitude and velocity dispersion of different types of galaxies. That can be used with linear modeling. Or the color magnitude data on the Combo 17 galaxies, which can be used for edge clustering. Those are the specific examples that we have provided with Astrowrap. Or properties of globular clusters of NGC 5122 galaxy. This is the one that we use with K-means, and we'll go into in the next slide. Magnitudes of lots of quasars are available in different optical wave bands. This is for generalized linear modeling. But of course, each of these data set can be used for any other test that you want to run, because there are many commonalities in them, though there are differences in terms of the number of rows available, the number of columns available in them, and so on. So here is how one would run the Kmeans example with the data set that has been provided there. The data set is for globular clusters in NGC 5128. You would load that simply by saying data NGC 5128. And then the columns that you have there are the ones that can be used for PCA. So you get NGC 5128 underscore PCA, that's what we are calling here. Then you can find out the summary for the Astrowrap command. And so Astrowrap summary with principal components of that will provide you a summary. I'm not showing the output here very deliberately. You can go through those examples. And then finally, you can get the k-means of that by passing the k-means method to Astrowrap. So that is how you would get the plot that we saw a bit earlier. So 3 different clusters is what it will come up with. So I encourage you to give it a try, see what you find with that. Now, another new thing that has come about just last year is something called Swirl, which stands for Statistics with Interactive R Learning. This allows you to learn R in R. So these are demos. Once you start something, it'll ask you specific questions, and then it'll expect you to give the correct answer, and then guide you into giving that answer in case you give it wrong. And then once you get a correct answer, then it'll move on to the next question, again guiding you by first showing you through some examples and so on. So we'll be combining Astrowrap with Swirl as well. So there'll be some Swirl modules that will be available with Astrowrap. So it is for educators and for learners. The original idea came from Johns Hopkins University, Nick Karchedi. And then you can find out more information on that using swirlstats.com. So you can also find on GitHub many different examples of Swirl. So again, that is another thing that I would encourage you to download and take a look at. Swirlify is another package that is available with Swirl. What it allows you to do is that if you have an interesting idea, then you can swirlify your idea using Swirl so that a demo can be made for your idea where you provide a set of questions and a set of answers for that. So you can also take a look at what we have swirlified in Astrowrap. So the way to load Swirl is fairly straightforward again, as usual. Library Swirl will do it for you, and simply invoking Swirl with empty parentheses will then tell you what are the different demos available within Swirl for you. And as I said, we have been combining it, and the example that you'll find in the sister website is using the linear discriminant analysis of that using CRTS data. Next time, we'll see how object-oriented programming handles the 2 different kinds of classes, S3, S4, and some of the other classes that are available with R.